All right. So I'm Nils Bore. I'm a researcher at the Robotics Perception and Learning Lab at KTH. And I'm here to talk about the SMaRC simulator and the kind of the surrounding infrastructure supporting all of the software development that we're doing for the vehicles. And I'm quite happy to talk about this topic because it's kind of outside of the usual research that I'm talking about, but it's a big part of what we're doing within SMaRC. Unfortunately, I don't have any video of myself showing, since I need to kind of run simulators on a beefy desktop that doesn't have any webcam. So please bear with me. Okay, so I'm going to talk about the software environment that we're running on the vehicles. And you can kind of think of it as a pairing problem, in that I'm going to try and draw here on the screen. Let me see, where do I... Sorry, I'm trying to find out how well, you can probably see my pointer. So let me go back. Okay. Okay, now I messed up here. Sorry, there we go. Okay. So basically, what we want to do is we want to facilitate the development of robust robotic vehicles. We're working with several vehicles, so we're working with Lulu, Sam, and also RAN to some extent, although not so much yet. We're also working with several people, so maybe 10 to 20 people that want to develop software for these vehicles.
You disappeared.
And yeah, like I was gonna...
Now you're back.
Oh, now I'm back. I was gone. Okay, so should I repeat? Okay, I'm gonna...
Just continue.
Yeah. Okay, I'm gonna continue. So basically what we want to do is we want to enable all of these people here that are developing for our platforms to develop on these vehicles over here. And there are a few problems that arise from this kind of setup. First off, we only have 3 vehicles over here. We can't have 20 people working on these vehicles at the same time. So we need to have some way of simulating these vehicles or somehow working with them without having direct access to them all the time. The other thing is that we can't always go in the water with the vehicles. So we need ways of testing while on land and then being able to deploy when going into the water. The other problem is that we have 10 to 20 people that are contributing to the same piece of code. So we need to kind of make sure that if someone modifies code, then it should run for someone else, and they need to be able to contribute to the same code base at the same time. So I'm going to talk about these problems and how we within the SMaRC project have set up infrastructure to address these problems. And that's split up into several different strands of work here. So I'm going to talk about each of them a little bit. First off, we have the SMaRC AUV ROS interface, which establishes a common software interface for all of our AUVs. Then I'm going to talk about how we release binary releases that everyone can install very easily. third, I'm going to talk about our simulators, and then about how we host our code and perform continuous integration to ensure that the code is running for everyone all the time. And then a bit about documentation, which is very important if you want to enable people to working on the same piece of code. I'm not going to talk so much about the ROS environment, but that's basically the middleware, the platform that enables all of the code on the vehicles to talk to each other. All right, so one thing that we've been working on for the last year is to develop this common interface that runs on Lolo and SAM, as well as on all of our simulators, and hopefully it will also run on RAN at some point in the future. That's kind of maybe more long-term, but let's see. And it's basically a common interface, a software interface that all AUVs can implement, and then you just need to develop a piece of code for one AUV and have it, or for this interface and have it running on all AUVs. And it lives in our common software repository in this SMaRC messages repository. And just a brief kind of overview is that we have all of these things running on the vehicle. So we have sensor input coming in, we're sending out control signals. And then we also typically have different kinds of controllers and planners running on the vehicle. So for example, controllers for controlling towards a certain heading or a certain depth, or planners for following a trajectory going somewhere. And this interface that we developed standardizes all of these interfaces, so you can have a defined interface for sending set points to the controllers, for example, or common interfaces for the sensor data. So as an example, we have a common interface for the DVL that we implement both on SAM and Lulu. We also have one for the side scan. And that enables us to have, for example, perception algorithms developed for the side scan on SAM to be used on Lulu as well. Right, then the second part I'm going to talk briefly about is that we now, since approximately half a year, have binary releases. You can very easily install the SMaRC system and run all the simulators and everything. And this enables basically everyone within the SMaRC project to run our code very easily. We also have virtual machines that you can use and try this out if you don't have a machine that's capable enough. But it also, I think, importantly enables outside researchers, for example, to try out our system and help us develop our system or collaborate with us on research papers. And once you perform this easy setup, you can just install anything that we develop using one line like this. For example, to install the Lulu simulator over here at the top. And yeah, I won't go into the details, but this is binary releases for Linux, basically. So that's why you need what you need to have this running on your machine. Right, then we have a few different simulators. First off, I'm going to talk about Stonefish, which is the main thing we use to simulate our full system with sensors, controllers, everything. It was developed at the University of Girona, and it's developed specifically for AUVs. And this is contrasting it to the main other simulator that's used by different universities, which is based on the gazebo simulator, which was originally developed for ground robots. And that's kind of limits its application to AUVs, which we discovered at the beginning of the project. So this turned out to work much better for our purposes. It supports a wide variety of sensors. It has high quality underwater rendering, supports simulation of the dynamics with currents and waves and so on. And I'm going to also get to that at the end, but we can also do headless simulation, which allows us to run continuous simulation in the cloud, which is quite interesting. Right, and then after you installed the simulation with the command that I showed you before, you can run it with this one command over here for SAM, or a similar one for Lulu. And I'm actually going to show you briefly how it looks now. So it's just a screenshot with Lulu and Sam, and I'm going to show you a simulation just with Sam right now. So let's go into the terminal and let me see. I'm going to run the command that I showed you here. So one thing to note is that the interfaces that we're using here are the exact same interfaces that we're using on the robot. So this is the exact same GUI that you also see that the operator uses when controlling the robots. And we launch all of the things in the same way. So now I'm launching the simulator itself. We're also running the same dead reckoning code that we're running on the SAM in this case. And also the same code for the controllers and mission execution. So if we want to look at one of the sensors, we can check one of the color images here. We see that SAM is rolling quite a bit. So what we'll do here is we'll just check out some of the actuators and see how that looks. Here you can also see that we have some waves going. So Sam is going, let me see if I can focus on Sam. He's going a bit up and down here in the water. So yeah, we can, in this interface, we can control the actuators. We can set the buoyancy so that Sam sinks. We can also set the longitudinal center of gravity to pitch back or forward. We can set the thrusters. Let's see here if we can turn them. And now it's turned. If you look at the thrusters here, it's turned a little bit. I'll put them back to the original position. And then we can also set some RPM speed for Sam here. So let's go at 700 RPM. Oh. Okay, now you can see the sun here and the algae farm. He's turning a little bit. Okay, and then we can also see if we can visualize Sam in Neptus over here. So now you can see Sam moving here around the algae farm in Christineberg. And we can also send missions to go around a mission planned in Neptus. Right, and one more thing that could be of interest is also that we have these sensors here that we can visualize. Oh, now he's rolling quite a bit, but we can okay, I think Sam went too close to the seat bar. So yeah, we can see the where all the sensors are looking here. We have multi-beam in this case in the simulator, and we also have a side scan, a DVL, and 3 cameras. All right, that's what I wanted to show about the simulator. Let's go back to the presentation. Okay, I got a message here saying that the frame rate is very slow. And I should mention that the simulator actually runs in real time. So if you're experiencing a very slow frame rate, it's probably because of my connection. Okay, so we were looking at the simulation. We looked at waves. Yeah, I simulated some quite extreme waves here, but I don't think that's so interesting to look at. Okay. Right, and then we have some other simulation environments. So Stonefish is very good in the sense that it enables us to simulate everything, all the sensors, the environments, but to really simulate the fine details of SAM's dynamics. In this case, we also have a more fine-grained simulator for that allows us to tune PIDs and so on. We also have a even more high-level simulator than Stonefish that allows us to run simulated missions as we check in new code online. So we can simulate giving a plan in Neptus and running the mission execution, the behavior tree, and see that all of that part of our logic is working. So about that, this is another one of the points that I mentioned before. We have this continuous integration setup that tests all the new code that's checked in all the time. And so we can make sure that all of the code is running, and if someone checks in some code, it's ensures that when someone else downloads the code, it will actually run for them as well. And we're also continuously releasing new binary builds. So if you go to our repository at the SMaRC project at GitHub, you'll see that we have these kind of indicators of what is working at the moment, which releases are working. So you can kind of quickly get an overview of the status of the project. And then I mentioned before that Stonefish actually allows running in headless mode without this fancy graphics that I was just showing. And the next step is to also run this online every time we check in new code. So we can basically run a full mission within Stonefish, try out the full pipeline that we would be running on the robots and see that everything is working. And that's really powerful and should really contribute to us developing more robust software. So yeah, this basically was an overview of the infrastructure that we have in place. We have this common interface that's running on the simulator that I just showed you, as well as on SAM and Lolo. So basically it allows one piece of code to run across these different environments, and hopefully in the future it could also run across other AUVs from other labs. Simulators lower the threshold to contribution, since if you don't have access to the vehicle right now, you can try it in the simulator instead, before actually trying on a vehicle. The binary releases allow us to very easily get the code, get it running very quickly. And then continuous integration ensures that our code is working. We can try these simulators all the time to make sure that we can run the missions that we want to run on the vehicle. And before checking in new code, this runs all the time. So it ensures the robustness of what we're doing. And then finally, I didn't really get to talk about that, but documentation is very important since it, again, lowers the threshold to contribute. All right, that was it. Thanks for listening, and I'll answer any questions.